Good morning, everyone. Welcome to the 50th episode of Gyaniki Tech Talks: How to Prevent EVs from Catching Fire. Our guest speaker for today, Mr. Rahil Gupta, is the co-founder and CTO of Hop Electric Mobility. He has been a technology entrepreneur working in the EV industry from past 7 years, has built $1 million monthly revenue business in less than a year, and has been also awarded 40 under 40 top achievers in e-mobility space in India. His core expertise lies in electric powertrain systems, high performance batteries, energy storage, connected systems, and new product design and engineering. Please join me in welcoming Mr. Rahil Gupta, co founder and CTO Hop Electric Mobility. Rahil, it is a pleasure to have you today with us.
Thank you, Rhythm, and thank you for providing this platform to share knowledge and build awareness for electric vehicle systems. Electric vehicle being a new technology, it is very necessary that the know-how and the knowledge sharing platforms emerge, and I guess Gyanki is doing a great job at it. So thank you. So, good morning, everyone. I hope I'm not bugging you more today. It's a Saturday morning, and I see a lot of people joining in still. So, it's a Saturday. Good morning, and right now I'm in Jaipur. It's 40 degrees here, and go to 44, 45 degrees by say 12 or 1 p.m., 12 noon or 1 p.m. And it's the same situation across India. Like in different geographies, the temperature has been rising, and people have been wondering. Electric vehicle has been in the news, right? Electric vehicle has been the batteries are catching fire, the brands are recalling the vehicles, and people are wondering if this new technology, which aims to disrupt the mobility market and which aims to disrupt the automotive segment of India, which accounts for a lot of jobs and a lot of revenue and economy for the government, will it sustain? Like, will it even sustain? Like, the people are worried, the manufacturers are worried, but I'm here to tell you that it's all in a short-term game. Electric vehicle industry is in good hands, and people are working towards creating robust and reliable systems which will sustain. Uh, Electric vehicle industry as a whole, it's not more a question of why, but only when. People are very clear that this industry will sustain, it will be here, and people will shift to electric in all of their mobility needs. It's a question of when, right? And with the previous accidents from last 6 months, we have seen explosive growth in the adoption of electric vehicle in India, and majorly in the space of two wheelers, right? So people have realized the economical benefits of using an electric two wheeler, the performance benefits of using electric two wheeler, and they want to shift, and they want to shift fast. The problem is when when there's a demand created at this momentum, there are a lot of people who want to cash in on that, right? And that is the reason you see there are 100 plus companies in India selling electric two wheelers, which are either knockoffs or just say imported CKDs from China. And these people are like the fly by night players will disappear soon. But the problem is it weakens the confidence of the consumer in the industry because he cannot differentiate today that which brand to trust, which company to invest in and be a consumer of, because automotive segment or automotive purchase is just not say 1 year or 2 year purchase like a mobile phone, right? Where the people are more agnostic to the brand. But it's more brand likely thing to be driven because there is trust and safety and reliability involved. It's a functional unit which takes you from point A to point B, and you want something that actually gets you there reliably and safely. So, from the previous accidents that have been happening, the battery fires that have been happening, the scooter failures that have been happening, I have been seeing a shift in the consumer mindset that the demand will be there. There will be no stopping that, and there will be no arguing that demand will not be there. The only reason is people are now more brand cautious. So they're more cautious about which brand to trust, what vehicle to buy, and what are the safety precautions that the company have taken, what are the technological developments that have been measured in-house, and what are the testing and reliability metrics they have passed, right? So these things will be more important right now. Consumer, because of the explosion in the EV industry in last year, consumer is now more aware. He knows technical terms like what is the capacity of the battery, what is the temperature that it goes into, what is the thermal runaway. So I was surprised that people know what is the thermal runaway, how thermal runaway happens, and all of those things. So we as an industry have a huge and a good load on our shoulders to actually say distribute this awareness in a programmatic manner so that there is no misinformation to the customer. That is first, and second, to build a robust and reliable supply chain and value chain across India, which delivers quality at scale. So that is our funda. What we want to deliver as an automotive industry in India was quality, but as EV industry, we don't want to just stick to the domestic markets. We want to deliver quality at scale, which can lead India to be at the forefront of electric vehicle revolution. So more about that later. Let's start with how we arrived here and what we are doing. So just to give you a little brief introduction about HOP and what we are doing. So HOP Electric Mobility, we I started with my two other co-founders, Nikhil and Ketan, 3 years back in 2019, and I was personally working in the electric vehicle industry. Ketan and Nikhil brings the in the expertise of energy, so they understand energy systems. They are into solar energy generation and all of those things. When we sat down, we realized that electric mobility is not just a challenge for the mobility industry, but also the energy industry. So, Hop Electric Mobility sits at the intersection between energy and mobility. We disrupt two markets. We have Hop Energy and Hop Electric as two vertical companies. Hop Energy deals with energy as a service. So we install charging stations. We are the first one in India to deploy electric battery swapping stations in Jaipur, where we were operational since last 2 years, and the pilot is still running strong. The basic funda was you buy the scooter without the battery, and the battery will be given to you as a subscription per month, in which you can drive unlimited number of kilometers, unlimited warranty. You don't have the liability of the battery. We take care of the battery. You'll find a fresh battery every time you swap, right? And we ran a fixed pilot of 50 batteries on a two-wheeler in India, and we were the first one to do it with two-wheeler. So people have been trying it with three-wheelers. We were the first one to do it two-wheeler at a deployed scale in Jaipur. This year, we have made the generation 2 based on the insights and the learnings from generation 1, and we'll be scaling it pan India across urban centers. Second vertical we operate in is Hop Electric Mobility. So there are some things which Hop Electric Mobility does. It's basically into design, development, and manufacturing of electric mobility products, primarily two-wheelers and primarily motorcycles and scooters. So we are running with the two models, Leo and Life, from past around 12 months. And then motorcycle will be launched next month, which is a high-speed frame-approved product. And then two scooters, which we were working on last 2 years, will be launched in August. So we have a healthy portfolio of products in the coming this fiscal, and we will be trying to scale this up. We have presence in 14 states, 107 exclusive dealership touchpoints, and we clock in around $1.5 million revenue per month as of now, which is going to scale at $10 million in the coming months when we launch the high speed products. So that is about the company. What we aim to do is actually create an integrated ecosystem of energy and mobility, where energy can be efficiently stored, transported, and consumed by the ecosystem without leaving much of the carbon footprint across the geographies. And to aim that, we are trying to develop products and solutions in both the verticals. So coming to the battery fires, I was just want to take you through a journey where how the battery is made, and then how we can make a safe battery, and probably what is going wrong today in the industry, which is leading us to these fires and whatnot. So before talking to the battery, I just want to have an idea of what the audience is like. So I don't want to go so simple or so complex. So Rhythm, just can we have a very quick poll of what the audience looks like? So how many of you are in the electric vehicle industry or working or want to work in the electric vehicle industry? Can you just give me a quick shout out? Say yes. Great, great. So we have a good fair number of them. Sure. So I found this. So one of my colleagues in a institute made this graphic a couple of days back, and I really liked it. And the reason I'm using this with all due credentials is because it actually summarizes the fundamentals of the battery pack in a comprehensive manner, right? And we'll discuss about this today in detail. But I'll just want to take you through a journey key why the battery is important and why people haven't yet solved this yet. Uh, so battery, as you may call engine in the case of a IC internal combustion engine, two-wheeler, battery is at heart of the vehicle, right? And by value, it's 40% of the cost, and by importance, I guess it's more than 80% of the importance in the vehicle. In the vehicle there are other subsystems which are actually which are important enough, but battery, because it's a new technology, people are not used to make such kind of battery packs, especially in India. It's a challenge, right? And because India being a price sensitive country, you have to deliver quality at scale and with a good price tag, because you have to reach that into the masses, right? It's a big challenge, right? And battery is something especially the lithium ion chemistry, is something that we just yet started to learn about, right? So we do not have enough data on us, because you have to consider there are many type of chemistries when you talk about batteries. The first type which comes to our mind is lead acid. The lead acid chemistry is actually a chemistry which is widely available in India. People use it for energy storage. People use it for UPS systems. People also use it as a replacement for DGs, grid level storage. Even say now, people, when the electric vehicle revolution started, it does not started with lithium. It started with lead acid, right? Initial of the electric two-wheelers that were sold in India was lead acid based. Even the e-rickshaws that are plying today on the roads, most of them are right now sold with the lead acid battery in the rural areas. So what brings us to the lead acid? What brings us to say replacing the lead acid? So lead acid battery, it kick-started the electric vehicle revolution. It had its own issue, and one of the major issues was the cycle life. Second was energy density. Third was replacement of the battery, and then content of the poisonous material which can be spilled quickly. And people in the electric automotive industry realize that it's not a good suitable battery system for the vehicle because of the nature of the application, right? So battery is something you need to design as per the application. It is not something you have single source of energy or a storage energy and you deploy it everywhere. Something which might work at a grid level does not might work at the automotive electric vehicle level, which would not might work at a another storage level, right? So it's all. So when you design a battery, the first thing you have to keep in mind is it's an application based product. So you need to actually deep dive on what are the exact requirements and how any of the storage systems you are delving into can help meet you those requirements, right? Second point was because of the cycle life challenge and the energy density challenge. So energy density in simple terms is the how much energy per weight and per volume you can store in a particular storage system. So for what do you call it? So it's measured into two things. It is either watt hour per kilogram, that is specific energy density, or watt hour per liter, that is volumetric energy density, right? So when you consider lead acid, the energy density for lead acid was less than 100 watt hour per kilogram. So when initially it was okay to use a lead acid battery because the electric vehicle was not seen as a serious competitor to the automotive industry, people were just testing the product. People were just fiddling with the idea of it can be used as an alternative to the electric two-wheeler or electric three-wheeler, can be used as an alternative to say a CNG three-wheeler or diesel three-wheeler or petrol two-wheeler. It was not a serious contender. But when the lithium ion chemistry came in and it began commercialization, and China and other players was the biggest beneficiary and the push like the flag bearers for the lithium ion. What did realized was lithium-ion chemistry was superior, far more superior than lead acid in many ways, right? It had more number of cycles. It is more stable. It's say more safer in say it does not have any poisonous content as say lead acid. Plus, the energy density and power density from lithium ion cell or lithium ion battery pack is far more better than a lead acid battery. That is the reason people started shifting to lithium ion because now China and other geographies have started to making and installing production capacities which was unparalleled in the world. Right, China leads the way into the world where the lithium ion production capacity for the cells is one of the highest. Right, you talk about any chemistry in the lithium ion, they are the one of the largest manufacturers of lithium ion cells. And when they pushed it, they pushed the prices of the lithium ion from say around $600 per kilowatt hour to all the way up to right now it's around $100 per kilowatt hour at scale for LFP, but yeah, around 100 and 150 for other applications. So that was a major reason because now lithium ion was affordable enough to go into automotive or the mobility segment, right? And and then the revolution happened because now you have a battery system or an energy system which can actually service the power requirements, the cycle requirements, and the life requirements for an automotive segment, right? And that when people realize that now the timing is right, now it makes sense to shift to electric, and now it is possible than ever before to invest a lot of capital, and that is why you see many people jump into the electric bandwagon in 2017, 2018 because that was an inflection point for the battery chemistry. Now in 2022, 2021, when you see a lot of demand, there was a pent-up demand that happened from last 3 years, and now everything is coming into place. The production are there, the companies are there, the services are there. People are pushing for the sales and all those things. But really, the battery system which were viable was in 2017, 2018, where people really realized that now this might be the solution for the electric vehicle. Electric vehicle now might not be just a dream; it can be a reality. And in India, being a price-sensitive country, you can have a techno-commercial viable product which can service the mobility needs of an Indian customer. So while we were doing that, we realized there were multiple chemistries, there were NMC, there were LFP, there were LTO, but we chose the one which is more stable, gave you a consistent performance. And then some people grew with LFP. There were some challenges with LFP, there were challenges with NMC. So, they also, for the lithium ion itself, they have a area portfolio of different chemistries, definitely based on different applications as well. But it also services the same application. So say NMC is nickel, magnesium, cobalt. So when we talk about these different chemistries, what is really happening is the cathode of that battery is changing. So instead of a nickel, magnesium, cobalt cathode, LFP cell would have a lithium iron phosphate cathode, right? The anode is majorly the same. It's a graphite-based anode. In lithium titanium oxide, the cathode is NMC or LFP, but the anode is mostly the silicon doped, or sorry, the titanium silicon doped anode. So it really based on what application and what power requirements you have that the lithium ion chemistry do have to go into the bike. So people started using NMC cells more, right? People started using LFP cells more for three-wheelers, NMC cells more for two-wheelers because of the energy density constraint. In two-wheelers, if you look carefully, you do not have much volume. You do not have much space to install a battery. Over that, because range is a matter of efficiency, you cannot put a heavy battery into a two-wheeler, right? You might have that flexibility, a little more flexibility in case of three-wheeler or L5 category, but in a two-wheeler, you're very strict on a budget in terms of weight, in terms of volume, and in terms of say packing that type of energy so that the vehicle can travel a range. When people are engineers who are thinking of doing that, they selected a chemistry known as NMC, which is high energy density, high power density, have a lower footprint in terms of volume because high energy density, and also can deliver a good number of life cycle if it is made a good path, right? So people started using NMC in 2018-19, and because China was also pushing NMC a lot, they proliferated the Indian market, sold the cells at a very cheap rate. So right now, what we see, major of the most of the chemistry that are being used, and plus has a consistent cycle curve and consistent discharge capacity curve. So people really love the chemistry and everything. But it came while all everything was good and fairy, but it came with one single challenge that because it's an active metal chemistry, it has a higher risk of a thermal runaway. I won't say it is going to, but it has a higher risk of thermal runaway. The thermal runaway temperatures for an NMC battery is much lower than that of LFP cells, so the tendency and the tolerance for the NMC cell to go into thermal runaway is much higher, right? So because of that, the risk was shifted to the consumer directly because people were not investing heavily on a battery pack design level. What they were doing was assembly battery packs at a minimum cost so that they keep in price competitive, keep either good margins or sell at a lower cost, and then get it to the customers. What they missed, which I believe when I look into retrospect of the industry, or what they didn't realize was this risk which they were shifting from say their own books to the customers is a safety risk, right? It's not a financial risk, it's not a other risk which people can observe and forget easily. It's a safety risk. If this happens, the safety of the consumer is on the line, and that is where the automotive standards and the other functional safety standards like ISO 26262 comes into play. And then people started realizing this year because only last year we were able to crack good volumes for the scooter so that they are present in the Indian market, and everyone was likes to cut corners in India. So they try to make the pack cheap while not investing heavily on how the pack will be designed. Right now, this was a journey that we entails in say last 4 to 5 years, which we discuss about it. Now I'll tell you what goes into actually making a pack, what goes into actually making a pack and getting a good pack out of say a factory and delivering it to the customer. It takes a lot of time, energy, and resource, but believe me, once you have a good pack, the product outcome of that process is not important. What is more important is the process. If you learn as a company how to develop and design a good pack, you are investing into the future. You are investing into your company's capabilities to develop good quality products at scale. And once you do that, the product itself does not become your IP. The process which the product is made from becomes your IP. And that is way more important than the product. And that is why when I consult other companies as well, I mentioned that you need to invest resources in investing and designing a good pack because the process and the learnings and the failures you go across designing a good pack is way more insightful and way more important than actually the pack itself. You might not end up with a good pack, but over time, if you just keep at it, you'll definitely learn. If you definitely keep the learnings and the insights, and with those insights, you can actually do a lot of things. You can do a good quality battery pack, just not for the automotive industry, but for other applications as well. And as of today, if we see everything and anything you mentioned is getting electrified. The transportation and the mobility sector, which is huge in itself, is getting electrified. The heating and cooling industry is getting electrified. The utility lighting and all of the other things are already electrified, and all of the other things like locomotives and everything is also getting electrified. So to service this type of demand, there will be batteries required everywhere. There will be decentralized storage, grid level storage, and to develop those good quality packs, you need to have that type of learning. And the only companies which will differentiate in the future will be ones who have invested in the process of designing good packs. That is why the process of that is very important. So the so what you can see on the slide here is actually what are the basic components which how a pack moves, right? So you start with taking the cells. So while you design a battery pack, the uh, first thing you take on the drawing board is the application. What type of application the battery pack will be succumb to? So say it's a mobility application, a two-wheeler application. Then you decide on the power requirements, cycle requirements, cost requirements, and other factors taken into consideration to start with, right? So that you can scale down on what is the exact type of requirements I have to. Once you freeze the requirements and you have a clear idea of what type of power density, energy density, what type of capacity, what type of thermal runaway, like if the pack will be subjected to high temperatures, will the pack will be subjected to high discharge currents, will the path will be subjected to even high mechanical shocks, right? So one thing that is very different in the automotive industry from say an energy storage industry is energy storage industry, say lead acid or any other chemistry, does not succumb to mechanical shocks or NVH as we like to call it in the automotive industry. Automotive industry standards are more tough because you don't know what is going to happen with that battery. Trust me. Why it's easy to create a normal battery pack, it's very difficult to create an automotive standard battery pack because that same pack can have a lot of NVH, a lot of vibrations, a lot of mechanical shocks in its daily life. And if you haven't designed for that and you haven't get those use cases into while designing and testing the pack, that will lead to safety issues. That will lead to functional failure. That will lead to pack not performing well because any wire can short, so any component can take off. And if those are not made for that mechanical shocks, the pack will definitely fail, right? And that is the number one mistake that people are making right now in India. They are making the packs, but not for mechanical shocks. So they do the packs, they have all the electrical testing, they do the electrical testing, and they're satisfied. The main reason the packs are failing because if there's a single mechanical shock that happens, the pack itself fails because any wire can short inside, any spot welding can, or spot welding or wire bonding can be deteriorated, or a lot of factors or second or third degree implications can happen when you're not designed for excellence. And designing for excellence is keeping like all the three basic parameters on the pack, say mechanical, electrical, and thermal intact in the design phase, development phase, and then also the very important the testing and validation phase, right? So coming back to the point, once you decide on the requirements you have want to achieve for that particular application, you start designing the pack. So you decide on the cell chemistry, which chemistry suits you the best in terms of energy density, discharge currents, temperature profiling, cycle life profiling, SOH degradation, all of those things. Once you do that, you consider form factors. You have a specific requirement for a pouch shell. So there are like mostly three form factors available right now. It is cylindrical, what you call 18650, 21700, 4860s, 32700, cylindrical form factors. Then there is a pouch form factor, which is like most of your laptops, most of your mobile phones. Carries pouch form factor. A lot of cars carry pouch form factor. And then you have prismatic cells. Prismatic cells is a cuboid shape. Like say if you consolidate a lot of pouch, you end up with a cuboid, right? That type of a cuboid shape form factor, which mostly goes into stationary energy storage, which mostly goes into e-rickshaws or three-wheelers or categories which do have some volume and space and do not require much of higher energy densities, right? So these are the three primarily used lithium-ion battery storage form factor, cell storage form factors, which are being used in the industry. And once you decide on that form factor, then you, depending on what type of operating voltage you want to go into, you decide on the series, what type of capacity like AH you want to go into, you decide on the parallel, and then once you do the series parallel, you go into getting the algorithms down. So people just start with series parallel, but there's one more step involved, that is fine tuning the balancing cell to what is the, say if one cell is at 4 and other cell is at 3.92. So there's a point 0.8 like 800 millivolts cell to cell differential voltage. How you keep it that? How you keep those cells balanced within the pack? Because minimum if the cells are balanced formally like uniformly across the pack, it will perform good because now when you discharge right the pack, any of the cell, if the cells is not properly balanced, any of the cells go into the lower cutoff, the whole of the pack will cut off. Might be possible other packs still have a good amount of energy left, but just because a single string hit the lower cutoff, all of the pack will go into cutoff, and you might lose 20 to 25% of your energy there, right? And just because you do not have a good cell-to-cell balancing, or cell-to-cell differential voltage is high, right? Then that is one issue, and you can solve that issue with many things like BMS sensing and control can solve that issue. Grading and sorting out those cells while manufacturing the processes to make sure the quality and the differential while you are doing the battery pack assembly is very important, right? So the MPNS theory you see here is a battery management system algorithm which actually sends the series and parallel and provide balancing current. So there are two type of balancing which happens into a BMS. It's either active or passive. 99% of the people use passive balancing. What passive balancing does is if one cell is higher voltage and higher capacity, it discharges that cell and dissipates the heat so that it can be balanced, right? So there are many balancing theories, there are many balancing algorithms. People use different, but yeah, the north star for everyone is to go to a minimum cell-to-cell differential or keep the balancing of the battery to an optimal level so that the pack can perform and give the maximum discharge capacity over a certain period of time, right? Once you decide on the cell, once you decide on the whatever series parallel, then you go into the structure. So I know this is the pack. I know these are the cells I will be using. I know this is the series and parallel of the cells I will be using. So say for the sake of this discussion, let's say it's a 20S 20S 20P cell, right? So 20S 20P cell means it's a if a cell is an NMC cell, so NMC cell are generally at 3.6 volts. So 20S means it's a 72 volt operating voltage pack, and 20P, if it's a, for the sake of this discussion, it's a 2.9 Ah pack. So for 2.9 Ah, 20P will be around 52.2 Ah, right? So it's a 72 volt, 52 Ah pack. Now you have done it, it's an electrical calculation. So you have done what is the voltage of the pack I will be needing and what is the capacity of the pack I will be needing. So series translates to voltage, parallel translates to the capacity, the H. So once you finalize on the requirement of that, you move into what exactly are the balancing algorithms, what are the BMS sensing mechanisms, what are the sensor placements, all of this. Before that, you also take care of cell selection. So cells, even for the same capacity, same voltage, are available of n number of grades, right? And right now, to be very honest, supply chain of all the cells is very tough. So it's very difficult to get to one cell and then only use that cell because it might can lead to an issue of supply chain availability, and if you ever fail to source your cells properly, you will not be able to produce it at scale, right? So people select two or three type of makes and what they want to use for, but the real question is ki, have they tested those cells to their desired conditions? So one thing we ad hoc we do is before selecting any cell set, getting it validated, we have a 9 month of accelerated testing cycle. It is generally 2 years, but from last year, what we have seen is because of the supply chain issues, we cannot really rely on a single or double supplier. We need to keep 3 or 4 suppliers just in case we do not have a supply chain for one, or we stuck with the supply chain. So what we do is a 9 month of rigorous testing and validation for each make. We select a model and then we use that models in certain of our products. So, for example, the last cell we selected was came into around January 2021, and we validated that cell till December. So it took almost a year, right? And once we validated, this year the supply has started, and we are making our packs using that cell. So in that process, we do thermal profiling, we do high discharge rate profiling, we do cycle profiling, how many cycles it can go, of course, in an accelerated way. We do high temperature profiling, like we take environmental chambers to do the cycling, high C rating, those things into the cell, and then we actually create a digital simulated model out of it. It is not accurate, but we get an idea because of the data we have collected that if the cell is exposed to this type of conditions, like if you only define the inputs, cell is exposed to this type of condition, what will be the output? Like how will the cell behave? Cell for many people, because we do not make it in India, we import it from China, and China only have a certain level of information that is being shared to us. It's a black box. Then we poke the cell. Cooking means when we give some input like a mechanical shock, high temperature, high charge current, or high discharge current. All of these are input. We do not know what will be the output still, and that is why these testing and validation stage is very important, because why you test it, you give them a longitude of different inputs, like you expose them to high temperatures, you expose them to high discharge current, charge currents, and you collect a lot of data on the output. And once you do that, you can create a good enough model and an understanding of that cell. And once you do that, you will be able to predict how will the cell behave if I expose them in n number of certain conditions. And once you have that type of insight, it is way easier for you to design a good thermally stable and a robust battery pack. And this is a step because people actually want to deploy things faster. This is a step people usually skip because they think it's a waste of time, energy, resource. But if you ask me, this is the only thing you need to do as a battery company. This is the only thing you need to do or invest as an electric vehicle company, because quality at scale will be only possible when you have the predictive analysis or say insights of how your cell will perform, right? Those cells were made and designed for certain conditions which were not Indian. Like they were designed for China, which have very low temperatures. They were designed for other US and European countries where the majority of the early demand came in. Right, so it is very difficult to predict how that cell will perform for Indian conditions when it's not designed for Indian conditions, right? That is the reason we thoroughly test and validate our cells. And once we do that, we start the battery pack process. We do the mechanical engineering where we do develop the aluminum housing casing for heat transfer. So we have a new material. So it's not a material per se, it's an alloy which is more thermally conductive, which is successful in actually dissipating the heat from the internals of the battery pack to the externals. And we use a lot of proprietary materials in that. We also use some ceramics and other materials which actually are more conductive. So facial materials, we use some gel-based systems to cool the cell and then get the heat dissipated from that through the middle housing, the aluminum housing, and then to the outside using convection. We have a lot of ways through which we cool down the cells. So structural integrity has to be maintained. As I mentioned, mechanical. So most of the fires which have been running for past 2, 3 months, 4 months, are, is poor pack design. I don't blame the cells. The cells are have to blame, but say 20-25%. Most of them are just poor designs. They don't know what they're doing. They are just assembling the pack as a process which have been told like cells and you keep the cells like this, pack will be made, but they don't know what they're doing, what type of cells they are getting. They're just into say बहती हवा में हाथ धो लेते हैं. तो उस case में if you're doing that type of things, people will not realize the value of testing, validation, design processes. So three things you have to keep in mind if you have to conclude. The first is cell selection, uh, cell testing and validation. That is the one. You do need to invest a lot of time and energy into getting a good cell, validating it for the Indian conditions. The second is the pack design, and by pack design I mean electrical pack design, mechanical pack design, thermal pack design. When you do it, you need to take care of safety. You need to take care of structure and control and how you manage it, right? So BMS, and the third most important thing is the BMS. BMS is the single hardware and the hardware and the software system which monitors and controls the battery pack. So it monitors and sends data out of the battery pack. And if anything goes wrong or out of radar or have a deviation, it has the capability of shutting the system down, right? It has the capability of making the system more robust. So investing in a good BMS which actually reacts, not the hardware PCB types, but a smart BMS. Here you have the CAM data, we have the data as of say, which you can sense, create algorithms over for SOH degradation, SOC calculations, predicting the life of the cells, and all thermal profiling, all those things, and then making a good quality process which enable these three things: good quality cell testing validation, pack design, structure, mechanical, electrical, and BMS. Once you combine all these things, you end up with a product which have right now, as of if I can say, infinite demand. It just not be used, has to be used in the electric vehicle industry. It will be used all across the globe, all across applications. Everything and anything which is getting electrified will use batteries. And what I believe is the future. In the future, all of those things which are electrifying have a storage system in the next 5 to 10 years. We'll use a lithium-ion battery, right? Or one chemistry or the other. Probably we'll be tweaking more to increase the safety, functionality, energy density, but we'll be using lithium-ion because there's no alternative to lithium-ion right as of yet, which is commercially viable. Technologically, there are many things which are being proven or being tested and validated in the lab, but nothing is commercially viable as of yet. So we have installed capacities of lithium ion across the world, which are pushing the prices down. we have new capacities of lithium ion in India. And just to give you a sneak peek, we were one of the beneficiaries of the Auto PLI scheme from India, from Government of India. And in that scheme, Hop Electric Mobility, I'm very proud to announce that will invest around 2,000 crore rupees in the next 5 years in just plant and machinery, out of which we will be allocating around 60 to 70% of that capital into creating a cell line in India, so that we don't have to face these issues again while we will be designing for excellence at a cell level. So where it all starts, like chemistry, material science. And we have been talks with a lot of companies to actually increase technologies for Indian conditions, modulate those chemistries, electrochemistries. And once we are able to do that, probably in a 2 or 3 years, we'll be setting up plant machinery in India to manufacture cells, so that we can have vertically integration all across till the cell level and create good quality products at scale for the group. Yeah, I would like to open the panel for the Q&A, and if you have any questions, so we can discuss.
Okay, so I think Rahil, we are good to wrap up. Very, very interesting thought, and this is the right now the topic of the day, right? A lot of conversation around the fires, and there is a lot more to see as we move along. So again, what Hop Electric is doing is very, very unique and taking the right engineering approach towards the development, which is I guess been a missing piece in the puzzle. So we wish Hop Electric all the best, and any parting words from your side?
No, I think I have spoken way too much today. So I'll just say that this industry is here to stay. It's not reversible. And we are sitting at a time that it's in our hand to make it like better, because if we follow good direction, good steps, it'll be here soon. If we do not follow those, we will make some cautious mistakes. We all will face some challenges, but we'll reach there. So it's just a matter of time. We want to be there soon than later, because of course we are facing the climate changes. It's right now 44, 45 degrees in Jaipur. Can't bear it. So in order to solve all these issues, we need to work towards it in a very collaborative manner. And I'm happy to collaborate and happy to take questions. You can reach me out on LinkedIn if anyone wants to reach out. My handle is Rahil Gupta, or you can also drop me if anyone see any synergies to work on, or probably have any questions regarding the battery packs powertrain. You can reach me on Rahil at the rate hopelectric.in. I will leave my email ID on the chat. We'll be happy to discuss. So, with that, I think we can conclude today's.
Yeah, thanks a lot, Rahil. Thanks a lot, and have a very energetic rest of the weekend.
Yeah, you too.
Okay, thank you.
Thank you. Thank you, everyone.